So we're going to go through these notes here, which are graphs of logarithm functions. Okay, what do we need to know here? Here is an exponential. Y is equal to a raised to the x. And you can see it right here. There it is. There's an exponential function right there. So nothing too crazy. There it is. Y is equal to raised to the x. What we're now going to see today is that a logarithmic function is the inverse of an exponential function. So if you come over here, here is our logarithmic function. Y is equal to log 2 of x. And can you see how these are both reflected across y is equal to x? And that is by definition an inverse function. So both of these are inverse functions of each other. There's a couple other things you can notice here. Do you see here for my exponential, I have a asymptote here. So I have an asymptote at y is equal to 0. And for my logarithm, I also have an asymptote, but I have an asymptote here at x is equal to 0. So that's been flipped as well, which makes sense if they're inverses of each other. How can we prove that one is the inverse of each other? Well, we know that if we want to find the inverse of this, what we do is you swap the x and y, then you solve for y. So let's do that. Let's swap the x and y. So it'll be x is equal to 2 raised to the y. And then if you solve it for y, it will be log of base 2 of x is equal to y. So we're utilizing our knowledge of logarithms to get the inverse of this. And the reason why we knew to do this is because we wanted the answer to be equal to y. We wanted to solve it for y. So that's why we use that. So as you can see, one is the inverse of the other. And you can see that in action here. To be the inverse means you're reflected across y is equal to x. Hopefully that made sense.